All right, so for number 8, it's again like the tricky one that we did before. So solid A is similar to solid B. If the volume of solid A is 21 inches cubed and the volume of solid B is 4,536, how many times smaller is solid A than solid B? Okay, so here we're saying how many times smaller. Okay, so basically we're saying that if we multiply solid A by that A cubed value, it'll give us B, okay? So if we do that, we know we're going to get a whole number, so that's why I kind of do it this way as well, because we know that A cubed is going to give us a whole number. The other way would be like a fraction. And plus, it's just asking how many times smaller, so they want a whole number, okay? How many times smaller? So for this, we just plug everything into this formula, okay? So we're going small times that A cubed value will give us big, okay? So A is the small one, all right? So A is the small one, so we're saying, again, small times our A cubed value will give us our big one, okay? Same way we set it up for the surface area one. So for this, we are going to plug in our values. So B is 4,536. A is 21. Multiply that by some value A cubed, okay? So then all we have to do is divide that by 21. Cancels, divide that by 21. So when we do that, we get our A cubed value to equal 216. Now, this is, again, they're asking how many times smaller. They're not asking how many times smaller is the volume. If they were, we'd be done, but they're not. So what we have to do is take the cubed root of that, take the cubed root of that, and when we do that, that's going to give us our A value here is 6, so it's going to be 6 times smaller. 6 times smaller. Okay, and again, we just did that because we set up our formula the same way we did before. Small times our A cubed value equals our big volume, and then we divide, take the cubed root. It's going to be 6 times smaller. All right, so moving on to the next page. So this one just asks what happens if you only change one dimension. So changing only one dimension, what it means is that the figures are not similar, okay? They're not similar. They're not growing at a steady rate. We're only changing one part. Only one part is growing, all right? So, therefore, we need another strategy. So, in this situation, basically, you're going to have to choose what we call these test values, okay? Going to have to choose these test values, and we'll talk about that. Basically, for the test values, you're always going to choose like 1 and some other number, okay? We're going to keep it as basic and as simple as we can for the test values, okay? Technically, you choose any ones you want, but we'll choose kind of the same ones every time. So calculate both the old and the new surface area volume, then compare your answers, okay? So when we compare our answers, basically what it means is we are going to have some fraction, and we're going to simplify some fraction, okay? So we're going to create and simplify a fraction. Simplify a fraction. That's all it means. When we're comparing, we put the one on the top, the other one on the bottom, and divide, simplify that fraction, and that'll give us our how many times larger, how many times smaller, or whatever, okay? So for number 1, okay, so it says how many times larger is the volume of a cylinder if the height is doubled? So this is go back and get those volume formulas out, all right? Write them down somewhere, have them with you. Don't do these problems without having those in front of you. Don't think, like, even if you want to Google it and look up what the volume of a cylinder is, that's fine, okay? That is fine. Like, any formulas you want to have in front of you, that is fine by me during any time you're doing notes, assignments, tests, or quizzes. I don't care. If you want to have your formulas in front of you, that's perfectly fine. So we will start number 9 on the next video.